Hello everyone, welcome to our lesson on finding equations. Alright, so this is the last part of the graphing we'll be working with in this grade. And last lesson, we worked with figuring out how to graph a graph based on a slope-intercept form. And of course, naturally, we have to learn how to go backwards as well. Okay, so our first set of questions here is to find the equations. Okay, so we only need two pieces of information, the y-intercept and the rise and run of a slope. I guess that's three pieces, but slope is just one piece. Oh, whatever. Okay, so look at our first graph here. The y-intercept is at 1. Right, so we know right away it's something plus 1. Okay, let's find a slope. To find a slope, we look for 2 points. Let's say this point here. So we can see here that we went up by 3 and went to the right by 1. Right, which means that our slope, or our y-intercept, is 0, 1. Our slope, which is rise over run, changing y over changing x. Right, we went up by 3, so that's 3 over the run, which is 1. We changing x by 1. So 3. Okay, and that's it. Our equation now is slope x plus intercept. So that's our first one here. Okay, let's try another one. Right here, the intercept is -1, so 0, -1. Find another point. Right, we go up by 3 here, and once again, we went to the right by 1. So here's y-intercept. Slope, exact same thing, right? Changing y is 3, changing x is 1. Combine together, 3x minus 1. Okay, like that. Same thing here. Y-intercept is 0, 3. And then let's find the slope. Let's take, say, this point here. We're going down now by 1, and going to the right by 2. Okay, so remember, we're always going to the right side for our slope. Right? I mean, technically, you can go to the left as well and then go up. Right? Again, it's as long as you pick one side, right? But generally, at least for me, I found it easier to always go to the right and then make the run, the y part, negative. Okay, so the y-intercept, 0, 3. And the slope, right? We know the rise is -1, changing y is -1. The run is 2, that's a changing x. Right, so it's -1 over 2. And solve the equation here, -1 over 2 plus 3. Right, but we notice here that we don't have that equation here. Right, the only other one has a round slope. But we notice here that this here isn't actually in slope-intercept form. Right, because if we rearrange it, right, we want y to be on one side. If we were to rearrange and move the x to the other side, we subtract -1 over 2 x on both sides. Right, we get the equation that we want. Right, so we sometimes it's not actually in slope-intercept form, so we have to rearrange the equation to get that. Right, and we're done there. All right. So once we find the equation, we can do anything we want. So let's take this one here. All right, let's find the slope-intercept. Y-intercept is at 2. Again, I'll always give you a dot for the y-intercept. Let's find another point, say this point right here. We're going down by -3 and going to the right by 2. Again, just to illustrate it, we could go backwards as well. Alright, so from here, we're going to the left by -2 and going up by 3. So as you can see, the result's the same. Right, it's either 3 over -2 or -3 over 2. They're both, at the end, -3 over 2. Alright, so again, I tend to do this one where I move to the right on the x-axis. Right, but as long as you remember the negative signs, they're fine. So it's -3 over 2. Like that. Okay, equation of the graph. We just clump them all together. The slope x plus intercept. That's it. That's an easy. How about the x-intercept? Right, so if you remember, the x-intercept is when y equals to 0. Okay, so when we plug that in, it's essentially where our line touches the x-axis. We inverse operation, subtract 2 on both sides. Divide both sides by -3 over 2. So -2 times -2 over 3, which is 4 over 3. Right, well, let's get some space here. Or more specifically, 4 over 3 comma 0. Right, so as you can see here, at 4 over 3, which is around 1 and 1 over 3, right? It's around here-ish. Alright, so it's a bit more than 1. As you can see, that's where it touches the x-axis. Okay, and how about this? Are those points on the graph? Right, so as we can see here, those points extend way beyond our reach. So we can just plug it in and check. Point here, M here. It's pretty much asking if x is 20, is y -28. Alright, let's check. Alright, so it's -28, -3 over 2 times 20 plus 2. As you can see, we can reduce ahead to get to 1 and 10. -3 times 10 is -30 plus 2. Okay, so as you can see here, -30 plus 2 is indeed -28. Let's check the other one here, N. You can probably guess it. If I'm giving you, it's like, oh, are those valid points? Chances are the other one is not valid, is it? But we'll check anyways. Right, we plug it in. 2 and 16 gets reduced to 1 and 8. Alright, so it's positive 24 plus 2. And as you can see here, those are not equal. So, n is not a point on this graph. Alright, so yeah, we just have to plug the points in to see if these actually make sense. Okay, so now what's the x-intercept? We can actually ditch the slope-intercept from altogether. Right, because like I said, realistically, all you need to graph anything is just 2 points. Point 1, point 2, line, then you're done. So we can actually achieve this by finding the y-intercept and the x-intercept. So the y-intercept, that's the easy part, right? We just plug in, well, I guess not really easy. Now it's kind of really depends. Right, so the y-intercept is when x is 0. So when x is 0, we notice here that the y equals to 8. Alright, so our y-intercept is x is 0, y is 8. And the x-intercept is when y equals to 0. Right, so it's 2x equals to 8. Divide both sides by 2. X is 4. So x is 4, y is 0. So those are our 2 points. Okay, and then that's it. All we have to do now, plug it in, right? It touches y at 4. Touches x at 8. Grab our ruler. Oops. That's it. Oh, hold on. I got it backwards. Whoopsie. I call a mistake. Y is 8. X is 4. There we go. That looked really off, but there we go. Okay, so it touches the x at 4, touches the y at 8. Once again, grab our ruler. Right, because if we convert that into slope-intercept form, right, we just rearrange the 2x. Right, we get the slope or the intercept at 8, but the slope is -2. Right? So you can see here, we go down by -2 and go to the right by 1, and this is our second point there. Right, so yeah, slope-intercept form still works, but sometimes instead of just rearranging, we can just plug in 0 for both of those points and then just connect them. Again, this is just an option that I'm giving you. Right, you can use whatever method you like. You can either rearrange it or just right, rearrange it or find the zeros. Okay, so from here, y-intercept, plug the x in as 0. Right, so it's 0 equals to 18 minus 6y. Right, we can rearrange this to get 6y equals to 18. Y equals to 3. X-intercept is 18 minus 6 times 0. Right, so that'd be 0. Divide both sides by 2. X is 9. So 9 comma 0. Once again, get our 2 points. Touches the y at 3, touches the x at 9. Okay. Oops. Oh, this one's a little off, but that's alright. Okay, that's our graph. Okay, and again, slope-intercept form still works, but you gotta be careful here. Now we can rearrange stuff. Alright, 6y over here, 2x over here, so it's positive. Oh, actually, let's worry about that later. Let's just rearrange stuff first. Alright, so we can move this 18 to the other side, so y is by itself. -6y equals to 2x minus 18. Okay, but now this is not slope-intercept form. I remember, slope-intercept form states that it has to be y by itself. Right, but right here we have a -6 in front of the y. So we have to divide everything by -6. Right, just so y is just by itself. Divide by -6. See, if I'm there, then that's slope-intercept form, right? This is not slope-intercept form. This is slope-intercept form. We can have anything in front of the y. So everything divided by -6 gets you that. So as you can see, y-intercept of 3, slope of -1, 3. Move down by 1, move to the right by 3, you get another point here. Okay, and then the last concept of is straight lines. Right, how about this? the x-intercept is 2. But you can see for every single value on this line, it's always going to be 2. Alright, so here, this is, oh, sorry, I got it wrong. Backwards again. 2 comma 0. This is like 2 comma 3. Right, point here, 2 comma negative 2. No matter where you go, the x is always 2. And now when that happens, this equation of the line is just x equals to 2. Alright, so for a straight line, it just means that the x is always the same value. So it's 2. And then how about a horizontal line? The y-intercept here is 0, 4. And at any point up here, alright, no matter where you go, the y is always 4. Right? So, if y is always 4, then that's our equation. Right, horizontal is y equals to that number. Vertical is x to that number. Just for fun, how about a slope? Right, so we know the y-intercept here is 4. Right, so something x plus 4. Right, and then how about the slope? Right, this rise over run, the rise is 0. Right, so to go from this point to this point, the y value doesn't really change. Right, so there's no rise here. How about the run? Right, technically it goes infinite. Right, because no matter what point you pick, right, no matter what point you pick, the rise is always 0. Right, the y value never changes up or down. So that's why our equation here is just 0. Anything 0 divided by anything is 0. So that's why y has to go to 4. But on this side, it's a little different. There's no y-intercept. So we cannot even. So that's probably setting us on red flags, right? There's literally no y-intercept. So how can we make an equation? And on top of that, we also have to find the slope. For the slope, in this case, the rise doesn't change. Or in the previous case, right, the rise is 0. But in this case, the run is 0. Right? Because we can see that no matter where you go, right, the left and right doesn't change. The x value is always the same. But as you can see here, it's something divided by 0. Right? It could be infinity, right? It could be any number divided by 0, which is illegal. We cannot do that in math. We cannot divide numbers by 0. Right? So we don't really have an equation for this one. Right? Notice how here it's y equals to something. But here it's x equals to something. And in all of our forms, so slope-intercept and stuff, right, it's always y equals to something, y equals to something. We cannot really have x equal to something as a equation when it comes to graphs and stuff. Right, and besides, there's no slope-intercept form because, again, there's no y-intercept here. So this is the best we can do. It's just x equals to 2, right? X doesn't change. It's just always 2. Okay, but that's it though, right? That's just how we work backwards. We first find where it touches the y-axis, and then we count the slope, and then voila, that's it. Okay, and of course, a new method that we learned to graph is just you find 2 points, the y-intercept, x-intercept. Connect the lines, or connect the dots, and then you're done. Alright, so with that being said, good luck practicing.